24, all right. Already dropped my marker. Sweet. So problem says 34, number 24. We're expanding using the distributed property. You said 24, right?
Yes.
Okay. 24. So we've got parenthesis y to the negative fifth minus 2y to the seventh x to the fifth. And then out here we have x to the 0, y to the fifth. Now, first thing we should do here before we start to distribute is make our lives easier for ourselves. What can we do to make our lives a little bit easier? Good morning. 10 push-ups, please. Do what?
X is 0, 1.
Right. So out here we have 1 times y to the fifth. So how can we write that, which is simpler? What can we write instead of x to the 0, y to the fifth?
1.
What? Say it again.
1 is y to the fifth.
Right, 1 y to the fifth, or just y to the fifth. Because if we don't have a coefficient in front of it, it means just 1. Now when we distribute, remember it doesn't matter if the y to the fifth is on this side of it. It could be in front, it could be behind, it really matters because it's multiplication. So we're still going to distribute it to both. So what do we get when we do this distribution here?
1.
Right, because we get y to the fifth times y to the negative fifth gives us y to the 0 or 1. Okay, what do we get when we distribute this here?
Y to the 12.
These other things stay.
Oh, minus 2. Y to 12.
Yes.
Oh my god. I think my handwriting is messed up.
Aha. Yeah, try to write clearly. Try to, the other thing that I think a lot of guys, this is sort of a general thing, it's not about anybody in particular, could do better with is space management within the boxes. Try to start up near the top and towards the left so then you have space to do other things. Try not to write too large. One thing I recommend is using graph paper for math. Graph paper. One of these days I'll get some graph paper math boxes made. Do the homework. Thank you. But anyway, okay.
Can we start doing like 3 and 4?
Or would you put your sport cut on first?
I am blind.
I mean, if you want to do 3 and 4, I'd be glad to check them. I'm just following what the recommendations are here.
I know, we had like, that's our problem on our test.
Yeah? You want to go over one of those?
Huh? I didn't do it. Like, I didn't do it.
Well, but we could do 3 or 4 anyway. Even if you didn't do it, do you guys want to do one of those?
Yeah.
One of 3 or 4? Okay. So we're looking at page 139 here in the textbook. So which one do you guys want to do? Do you want to do square inches to square meters or inches to kilometers? Okay, square inches to square meters. So number 4, we're going from 320 square inches, no, 3,200 square inches to square meters.
Wait, what page is it?
139. Okay, we're going from square inches to square meters. Now, do we have a conversion directly between inches and meters? Anyone?
What? Yeah, it's like, so you have to go to centimeters and then you.
Right, we're going to go from inches to centimeters to meters. We're not going to go directly from inches to meters. We'll go from inches to centimeters to meters. Okay, now what I'm going to do to start setting this up? Yes?
I think I'm
No. What are we going to do to start setting this up? What are we going to do to start setting this up?
Fraction.
Right, we're going to write this first number as a fraction. What's it going to look like as a fraction? Oh, good morning.
I was not expecting.
Once you get your seat and get dress code, please give me 15 push-ups.
15.
Yes. 15.
Oh,
You could
do 15.
That's true. Okay, so what is this going to look like? So please don't distract my students while we're trying to do this problem.
It's up to me.
Right, you made
How are we going to write this?
it.
To do your push-ups? Yes. How are we going to write this?
Oh, you're not right.
Right.
Three,
3,000.
3,200. You got a billion on.
What am I gonna write? Don't
Yeah,
bend
what's so
your
funny?
don't bend your spine.
I'm not.
You are
Yeah.
right.
You gotta keep your abs flexed. Your body stays straight.
Am I doing it wrong?
That's better.
Okay.
I'll show you how it's done in a minute. So 3,200, but that was definitely not 15 of those.
Yes, it was.
No, that was
actually said that.
Bro, that's what happened at practice
Well, I
yesterday.
did tell you to do that.
He made everyone do non-stop push-ups because he
Because
didn't
I
want
do
to
them
do chest
fast.
push-ups.
Please give me 5 more. Just to be sure.
25?
5.
Yeah, no, 25. That's what he heard.
No.
He heard it. That's what he's doing.
I gotta tell my father about this.
Bro, I did. 5? Bro, that's so funny. What are you doing? That's not
All
a push-up, bro.
Alright, we can have this discussion later. Right now, we're trying to. There's a request to go over unit conversion like this, so let's do this. So we're going to go from inches to centimeters to meters, but first we have to set it up correctly. 3,200. What else are we going to write here when we set it up?
Over 1.
Over 1, but we need something else.
And then you're gonna put inches.
Well, remember square inches.
Yeah, inches.
Yeah, inches times inches.
And then you're gonna put 1 inch on the bottom.
Right, so now we're going to try to get rid of inches. We need to get rid of inches and go to centimeters. So we need, that's what. Hold on. We need to get rid of inches first and go to centimeters. So, yes, what are we going to write here?
2.5 centimeters over 1 inch.
Right, because we're getting rid of inches, so they go on the bottom. Centimeters is what we're going to, goes on the top. So that gets rid of 1 set of inches. Now what do we have to do?
Do it again.
We have to do it again because it's square inches. We don't just have inches this way, we have inches this way also. We got to convert them both to centimeters. So we do the same thing again, 2.54 centimeters over 1 inch. That'll cancel out the other inch there. Now, what do we still need to do?
Can we get it to meters?
Now we got to convert from centimeters to meters. How are we going to do that?
100 meter over 1 cent. I'm sorry, 1 meter on the top, and then on the bottom 100 centimeters.
Right, 1 meter on the top because that's what we're changing to, 100 centimeters on the bottom because that's what we're changing from. Cancels out 1 set of centimeters. Now what I still have to do?
Same thing.
Do it again, 1 meter over 100 centimeters. Okay, that cancels out the other centimeters. At this point, and this is why I recommend writing out all these units and crossing them out. Because now I can see by looking at it, I've canceled out all the units that I'm supposed to be going away from. The only units I have left are meters times meters on the top, which is square meters, which is what I'm supposed to have. So, what do we get when we put this all together as one big fraction? What am I going to have on the top of the fraction?
3,200 times 2.54 squared
Yeah,
over 100 squared
right.
meters.
Meters, thank you. Yes, units. Don't forget your units. No, not meters, square meters.
Yeah.
Yeah.
Wait, what page are we on?
This page 139. This is from the homework last night. Do you have it?
One more class.
34. Well, I assigned it a couple days ago.
I think I already did it.
Due today.
Yeah.
This one was not assigned as part of the homework. This one you could skip, but there was a request to go over unit conversions.
I know my contact.
What?
My contact. I mean,
No, do
Hey,
that
wait,
at
put 'em in.
home. Do that at home.
Wait. You have to go somewhere to do this?
well, I mean, what do you want me to not freaking put them on without a mirror? I mean,
I don't know how this works.
Use your phone, use your
Fine, go ahead, and then give me some questions when you get back.
okay, that's alright.
Fine, I know you were here early enough. You could have done this.
Well, I had some very,
Had some
very.
important conversations to have.
Yes, exactly. Very, very.
Go, hurry.
I should get contact.
What was that?
I should get contact.
I've considered it a couple times. Yes? No? Okay.
I know you can't see with your glasses on, it's too far away.
Well, yeah, I'm not even thinking about that. Just anyway, I don't know. They're kind of expensive and not a hassle.
How much are they?
Contacts?
Yeah.
I don't know. It's like I think it's like $50 or $60 a month.
Yeah, that's not expensive.
A month?
Yeah, that's not expensive.
It is full.
Well,
How much not $50?
compared to glasses, which my uncle makes for me,
How much is it?
That's what my uncle does for me.
He's makes them.
He makes glasses.
That's cool.
That's what my dad used to do.
So your family is like a line of like glass makers.
Well, so
Glass.
my great great grandfather owned a jewelry shop in San Salvador, and then his son moved to the U.S. with his family, And so his son, my great-grandfather, and my grandfather, they opened up, they had a bit of this background in jewelry. They moved into making glasses. So they were opticians. They also did hearing aids. And then my dad did that also until I was in middle school. They closed the family business, and then he became a teacher.
Who your dad did?
Mm-hmm.
You should become a glasses
Yeah, the problem is, like, the family business was closed then.
It'd be like instead of going to like American Eye, you'd go to the Orions.
Yeah, it was called Oriani Opticians.
Wait a minute. So
They were open
never-
for like 50-something years.
If they never closed, you wouldn't be here right now.
I don't know. I don't know what would have happened. I mean, things would have been different. Maybe I would have worked there. Yeah. Life's weird like that. Like, weird random things happen and they change your life in surprising ways. Like, my life has had a lot of things like that. Okay, anyway. Other problems from problem set 34 you want to go over. How about these ones that involve greatest common factors? So which ones were those? Numbers 20 and 21. You guys feel comfortable with 20 and 21?
You already had.
Okay, so for 20,
No
was-
way.
for 20 it was 2ab squared c.
Wait a minute.
And for 21, it was 5xy squared m squared.
So 20 was what, 2ab?
2ab squared c.
Yeah,
Yep. And then 21 was 5xy squared m squared.
yeah, I got that.
Okay. So for each of these, remember, you have to look at each term and ask yourself, what's the biggest thing that I can divide out of every single one of these terms? Because it's got to be a factor, something you can divide out of something. And it's got to be common. It has to be shared between all of them. Try not to turn your wrists in so much. It turns your elbows out and puts strain on your tendons.
Oh, you were freaking like a
And greatest, quiet. Greatest, we want the big, please be quiet. We want the biggest thing we can divide out of all of them. So for example, if you look at number 20, yes, it's true that we can divide 2 out of each of those terms, but there's more than just 2 that we can divide out of them. Right? We can divide A out of each of them. We can divide B out of each of them. We can also, not only B, but B squared. Because notice, we've got 2 copies of B in the first term, 3 in the second, and 4 in the third. We can also divide C out of each of them. So all those things together make up your greatest common factor. 2ab squared c. Questions about either of those or anything else from 34? Okay, I have a couple tests. These are test corrections from earlier in the year. Back. This is from last quarter. So just returning these. But the ones that you got back. So yeah, and then I'm going to get back to tests from yesterday. Then we're going to go over those. These were pretty good. I think the average was a B or something. Okay, it's test 7.
I've never actually seen what correction look like.
That's how I do it.
No, like, yeah, no. Mr.
Oh.
Deborah, I don't remember ever found back my correction.
Yeah, sorry that it took me a while. I guess I should mention that I think we had our first perfect paper of the year on this test. So I want to congratulate Ashton on that. Oh, I was confused. Okay, so there are a couple that I want to go over, then I'll open it up for some questions. Where's my copy? Okay, first one I wanted to talk about, these are just ones that I noticed a lot of guys had some issues with. First one is number 12. Number 12. And I think what happened with number 12 is it was just the fractions. You got to make sure you're comfortable with fractions. 12 is not difficult in terms of the algebra. It's very easy in terms of the algebra. It's the arithmetic, the working with the number, the manipulating the numbers themselves because they're fractions that caused issues here. So 12, we're trying to solve this equation. 1/4 x minus 1/4 equals 3 3/8. So what's the first thing we have to do in order to solve this equation?
Add 1 1/4.
Add what?
Add 1/4.
Add 1/4 to both sides, right? Because we're subtracting 1/4 over here on the left. We're trying to get that variable by itself. We want to get all the constants over to the other side from the variable. So we add 1/4 over here, and then we add 1/4 over here. Now what happens, so this will be 1/4 x. What happens when we add 1/4 to 3/8? Or to 3 3/8? What are we going to get? Anybody? How do we add fractions? They have to have a common denominator. So what's the common denominator going to be for 3 3/8 and 1/4?
8.
8. So how can we rewrite 1/4 to make it have a common denominator there?
2/8.
Right, we could say 2/8. Okay, great. What's 3 3/8 plus 2/8?
3. Oh, yeah, 3/5.
What?
I mean, 3 5.
3 5/8, right. So we had 3 3/8, and then we added another 2/8, so now instead of 3 extra 8s, we've got 5 extra 8s. Okay. So first thing, adding fractions. Second thing, what are we going to have to do here?
Divide
By?
1/4.
Divide by 1/4. What's a little bit easier than dividing by 1/4?
Multiplying by the
We could multiply by the reciprocal. What's the reciprocal of 1/4?
4.
4. So which one is easier, dividing by 1/4 and multiplying by 4? Yeah, in fact, they're the same thing. Remember, that's why the keep, change, flip works. The keep, change, flip, we can change division to multiplication if we're multiplying by the reciprocal of them. Okay, so we're going to multiply by 4 on both sides. That cancels out, multiplying by 1/4 there, multiply by 4 here. So x is 3 5/8 times 4. Now, how do we multiply a mixed number by something else? What are we going to have to do to multiply mixed numbers or divide mixed numbers?
8 times 3 plus 5.
Now you have to turn it into a.
Right, we're turning it into an improper fraction by multiplying 8 times 3, we get what? 24 plus 5, 29 over 8. Okay, 29 over 8 times what?
4.
Times 4 over 1. Okay. What should I do now? No. I mean, I could multiply, but there's something easier to do.
Cancel.
I can cancel out. What can I cancel out?
4 and 8.
The 4 and the 8. What will the 4 become? And the 8 becomes? 2. Okay, so now I can multiply. And what do I get? 29 over 2, or 14 and a half.
Yes.
That's all that it is. In terms of the algebra, very easy, but you got to make sure you're comfortable working with fractions. Adding fractions, we need a common denominator. Multiplying fractions, including mixed numbers, is pretty straightforward, but with mixed numbers, we're going to have to convert them first to improper fractions. Questions, comments, concerns about that one? 13 is the next one that I want to go over. I think there was just some confusion because there are so many terms in 13 that some of you guys got a little bit lost. We've got negative 2x plus 2 plus x minus 5 equals 1 minus 2x minus x plus 5. What's the first thing that we should do here when we have a problem like this? Anyone?
No. I should put the process on one side.
Even before we start moving things around between one side and the other side, what can we do first? Many. I can combine some of them. So if I combine my like terms on the left, what am I going to get? Right, so which ones are like terms? Negative 2x and x, those are like terms. Why are they like terms? They both have x, and there's the same exponent on x, which is 1. Okay, so negative 2x plus, how many x's is this? 1. Negative 2 plus 1 gives us? Negative 1. Okay, so negative 1x or negative x. And then what else do I have on the left when I combine like terms? We combine 2 and negative 5, we get negative 3. So we've got negative x minus 3 on the left. Equals, and what am I going to get on the right?
Negative 3x.
Negative 3x Plus 6, yes. I think some guys might have gotten a little confused here about this 1. That's a positive 1. Even though there's that negative sign after it, this is a positive 1 minus 2x. So we combine the 1 and the 5, we get positive 6. Minus 2x minus x. We've got negative 2x and negative 1x that we're combining, which is going to give us a negative 3x. Once we get to this point, what am I going to do? Put the variables on one side and the constants on the other side. So what should I do to do that? Okay, we'll add 3 to both sides. What else are we going to do? Say it again.
Add negative 3x.
Not add negative 3x.
Oh, make it 9.
Okay, well, but this will move the constant to this side. We still need to move all the variables to the left side then. We've got the constants move over to the right. How are we going to get the variables to the left?
Add 3x.
Add 3x, yes. Yeah. So we've got negative 3x, we add 3x, we add 3x over here. Now what do we get? 2x equals 9, so x equals 9 over 2 or 4.5. Yep. Yes, but I want to do, I want to do 19 and 20 first. Actually, I don't want to do 19. 19, I just want to mention, 19, all you have to do is add these 3 fractions together, or these 3 mixed numbers. Well, depending on what you got.
Minus 17 over 12.
Yeah.
You fill the simplify.
Right, so you have, well, here are acceptable answers. Mixed numbers are fine. Improper fractions are fine. What we don't want is something like this, 9 and 17 over 12. Because there we have it's both a mixed number and an improper fraction. If we're separating out the whole parts like this, we should separate all of them out. So what's a better way to write 9 and 17 over 12?
10
10n,
5.
5 twelfths, right. Or if you wanted to just change it into an improper fraction and write, what, 125? No, yeah, 125 over 12.
I do get 5. If you add 5.
120.
So you do 12 times 9.
No.
You could have done that on
10
the.
and 5 over 12.
Okay, because 17 over 12 is what? That's bigger than 1. We've got pizzas cut into 12 slices. I give you 17 slices. How many whole pizzas did I give you? If you try to take those 17 slices, they're each a 12th of a pizza, and make a whole pizza. How many whole pizzas can you make? 1. And then how many slices are left over? Right, because we took 12 of these 17 slices and we made a whole pizza. And then we had 5 left over. Say it again?
It's basically the same as 12 times 17.
Right. Yeah, it's the opposite of changing a mixed number into an improper fraction. We ask ourselves, how many times can this go into that? And then what's left over? Okay. 18 and 20. These geometry problems continue to cause stress and difficulty. For 18, two ways you could have done it, or 3 ways really. What's the way I'm going to tell you to do 18? Nope. That's one way you could do it.
Oh.
How am I going to tell you to do this one?
Find the triangle and the rectangle.
Come on.
Find the equation. So 20 times 14.
Not 20 times 14. What's our formula for the area of a trapezoid?
Length 1 plus length. Oh, 20 plus 14 times 8 divided by 6.
Yes.
Good job.
Base 1 plus base 2 times height over 2. Which will give us, base 1 plus base 2 is 34. The height is what?
8.
8 over 2. Okay. It's going to be what?
34 times 4,
Or, yeah, 34 times 4, which will give us,
136.
yeah, 136 square centimeters. Yes. That's one way you could do it. What's the other way you could do it? Or two other ways you could do it.
I did it like, I cut the triangle off the top.
Like this. Okay, then,
8 times 6. Divide by 2.
okay, so the triangle, right, so the triangle is 8 times, this will be 6 here then. 8 times 6 over 2, so it's what? 24.
And then I did 14.
Yeah, length times width for that rectangle, 14 times 8, which will give you 112, so the area of the whole thing then is 136. The other way you could do it, which is what the book suggests, but I don't recommend, is that you cut it into two triangles like this. And so the one triangle, the one triangle is 8 times 14 over 2.
That's so much easier.
It's 20. No.
What? No, 7 times 8 is 56. 8 times 14 over 2 is, yeah, it's 56.
Yeah.
Right, because we can distribute the 2, we can divide 14 by 2, we get 7. So 8 times 7 is 56. And then the second triangle, the base of that is what? 20 times what's the height? And it's also 8, yes. Over 2, we get what? 80. Okay, so the area of the whole thing is 80 plus 56, or 136.
That's really weird because I didn't know, like, you don't know the height.
Actually,
Yeah, you do.
Huh?
The height's there.
Oh, yeah, I mean, I just think it.
Yeah, this is why I don't like this one, because you can get confused about the height. This 10 that they put here, by the way, that's just a distraction. The length of that side is completely irrelevant for finding out the area of a trapezoid. You never use that side. We just don't. The only measurements you're going to need are the two bases and the height. So yeah, you could have used any one of those three methods. I'm always going to recommend the first one. With one like this, where there's only a part sticking out on one side, you could use this one. If there are parts sticking out on both sides, this one's going to be annoying to use. This guy here is what the book tells you to do. That one's fine. I'm not a big fan of it. I would just say this. Learn that formula. That'll get you the area for a trapezoid every time. Questions about that one? Okay, let's do 20. Just the last one I want to go over. Again, these geometry problems. You have to just know the formulas. If you don't know the formulas, learn them. It's like your times tables, but for geometry. Without knowing them, you're just not going to be able to do this. So, we've got a right triangular prism.
wait, sure.
Yeah,
Wait, how long are we going to be in person?
No.
at least until Monday.
That sucks.
No, it doesn't, but, you know.
What's the formula for the surface area of a right solid? Any right solid. Give me the formula for the surface area. If you don't know this,
I do know.
find it in your notes and then put it into your brain. 2 times what?
The base plus perimeter of the base times height.
Yes. 2 times the area of the base plus perimeter of the base times the height. Now, what's the base here of this right triangular prism? The triangle. The triangle in the front and the triangle in the back. So, what's the formula for the area of that?
Is that 8?
What's the formula for the area of a triangle?
Base times height divided by 2.
Base times height over 2. Okay, so how are we going to find the area of this triangle?
I can't see that. Is that 5?
But you had the problem there also when you're trying to keep my big head.
8 times 6 is 48. Divided by 2 is 24.
24 square feet.
That's on both sides.
Okay.
Yeah, we're gonna wait.
10.
We're gonna wait. We're just gonna find the area of the base first.
No, for the perimeter, I forgot to add.
Oh, you forgot about the 10. Yeah, now we need the perimeter of the base.
It would be 24.
Yeah, it's just 10 plus 8 plus 6 is 24 feet.
And the height is 12.
And the height, right, is the distance between those two bases, 12 feet.
And the equation with everything plugged in would be 2 times 24 plus 24 times 12.
Yeah, 2 times 24 is
Is 48.
48. 24 times 12 is?
It is something.
It is like
Yeah.
240.
No.
288.
Not.
Wait a minute. 24 times 288.
Yeah, it's 288. One way you could do that, 24 times 12, first we can do 24 times 10, we get 240, then we need to add on 2 more 24s. So we add 48 onto 240, we get 288. Okay, so then the total is
336.
336. What's a quick way to do that in your head? This addition here. To add 48 and 288, a quick way to do that in your head. An easy way to do that in your head.
8 plus 8.
48 is almost 50. 288 is almost 290. What's 50 plus 290? That you should be able to do in your head. Is what?
240.
340 is 340, but we added 2 to each of these before, so now just subtract 4. So 340 minus 4 is
It's too early to have math.
336.
Math class, last class.
All right,
I'd rather have math first.
other problems from the test that you want to go over?
How did I get
Wait, why are math classes?
number 16? 10.
Why are math classes always the first classes?
It's tradition. Which one? I don't know. 10?
You should have Latin first period. I don't know what I did.
Yeah, so 10 is just functional notation. So remember, when we have this functional notation, f of x equals 3x minus 2. Then they ask for f of 3. What that means is take that thing, 3x minus 2, and plug in 3 there instead of x. That's what functional notation means. F of x means do this thing to x. We're going to call it f. F of x means do this thing to x. So f of 3 means do that thing instead of to x, do it to 3. So where we had the x's there, we just substitute 3. So we replace the x and 3x minus 2 with 3. We get 3 times 3 minus 2. Which will give us what?
1.
7. Yeah. 3 times 3 is 9 minus 2, 7.
Number 16?
16. 16, you got to keep in mind that where the parentheses are matters. That first term, negative 4 squared, what's that going to become?
Negative 8.
Nope. What's 4 squared? Yeah, 4 squared is 16, and we need it to be negative. So first we square 4, we get 16, then we make it negative. With the second term, we're squaring negative 3, so it'll become negative 27, minus negative 27, will end up being positive 27.
Don't negatives right there cancel out?
No. Well, not directly. First, we need to cube negative 3, which gives us negative 27.
Yeah.
Then we have minus negative 27, and those two will cancel out.
Yes.
That's how it works there. It's not, the canceling out never happens before the exponents. And then with that third term, first we square negative 2. What happens when we square negative 2?
Negative 24.
Positive 4, and it's subtracting 4. What's the 4th root of 16?
16. 2.
Yeah. Those powers of 2, you should learn to recognize them. 2, 4, 8, 16, 32, 64, 128, 256, 12, 124, 148, etc.
How do you memorize this?
I don't know, it's just, they're common patterns.
Now you can show that.
That's why, like computers, you often see, well, I guess this is less of a thing now. You still see it with hard drives and things. This is why your devices, the number of gigabytes that they have available on them, will usually be, will often be one of those numbers. So it'll be something like 16, 8, 16, 32, 64, 128. All of these numbers, like a gigabyte, for example, is 1,024 bytes. It's always powers of 2. Why 2s?
Because it's.
I keep on,
Why do computer things care about 2s?
I don't know, for the two batteries.
2 batteries?
Um,
Electronics work using binary.
Oh. that's
Ones
right.
and zeros. There are only 2 options with binary. You count like this in binary: 0, 1, 10, 11, 100, 101, 110, 111, 1,000, etc.
Oh, so it just goes like.
Right? Because you don't have other options. After 1 comes. Anyway, we won't talk about other.
Now you don't tell you.
Yes. All right.
I'm forgetting how small
Goodbye.
space is in phone. Like my computer has 3 terabytes of space.